Hello my dear friends, I welcome you all for SVK tutorials. Those who are not subscribed to my YouTube channel, do subscribe to my YouTube channel. In this video, I am going to discuss the solution for Model Question Paper 2 for the 4th semester BE degree examination with the subject title Mathematical Foundation for Computing Probability and Statistics for that too for Computer Science and Allied Engineering branches with the subject code 21MATCS41. So in this paper 2, so I will be discussing the continuation whatever I discussed in the previous video. So the relations and function, that is from module 2. I am taking the module 2 and I am going to solve the questions of question number 3A, 3B and 3C. I will be solving these three questions in this video. Now coming to the solution part. So this is the given question 3A. So the given question is what here? Let A equal to the set 1, 2, 3, 4 and B equal to the set 1, 2, 3, 4, 5, 6. So they are asking to find how many functions are there from set A to B. That is one. Next, similarly continuation. How many of these are 1 to 1? How many of these are 1 to 1? Next, how many are on to? So similarly, the second question is how many functions are there from set B to A? Continued. How many of these are on to? How many are 1 to 1? See, my dear students, this is just a reference question paper for you. So they may ask only question number 1 or both here. So just it is a reference. So this is the way of asking the question in your examination. Okay. So let us see the solution part. So given, write down given, what is given? Given two sets, that is set A 1, 2, 3, 4 and set B is 1, 2, 3, 4, 5, 6. So find out the cardinality of A. What is the cardinality of A? So cardinality of A is the number of elements contained in that set. The number of elements contained in that set. How many elements contained in that set? 1, 2, 3, 4. So 4 counts we got, therefore cardinality of A is 4. That is what I have written and I will name that as M. Similarly, the cardinality of B, the number of elements contained in set B is how much? 1, 2, 3, 4, 5, 6. 6 elements we have. So therefore the cardinality of B is 6. I will name that as M. So cardinality of A has been denoted by M and cardinality of B is denoted by N. Now I can say that M equal to 4 and N equal to 6. Moving on to first question, what they are asking, how many functions are there from set A to B? So to find out that, this is the way to find the solution. Number of functions from A to B is given by a formula, cardinality of B to the power cardinality of A. So cardinality of B is how much? That is 6. That is 6 power 4. 4, how we got 4? The cardinality of A value is 4. Therefore 6 power 4. Calculate using your calculator. You can calculate that value. So you are going to get this value as 6 power 4 as 1296. Now moving on to continuation of that question. So they have been asked how many of these are 1 to 1. So how many of these are 1 to 1? So the number of 1 to 1 function from the set A to B is given by N, P, M. This is the standard formula. We are going to apply a permutation here, that is NPM. NPM is given by, so you know what is N, that is 6 and you know what is M, 4. So find out 6P4. You can make use of your calculator. See, you can use your calculator like this. I need to find out 6P4. So I will type 6. Then I will need to find permutation. Shift. Here we have NPR. See here in cross mark we have in multiplication symbol. Above a multiplication symbol we have NPR. For that reason I have pressed shift this cross mark. So we are going to get P4. 6P4 equal to, I got 360. That's all. This is a very simple problem that have been asked in a model question paper. If you got this problem, it will be very helpful for your examination. This is the way. So next, moving on to next further question, what they have asked. So how many are on to? So these many functions can be one to one. So 360 values, the value 360 represents one to one function. Similarly, how many of these are onto? So I can say that there is no onto function itself. There is no onto function. It cannot be taken place onto function according to the definition of onto. So friends, the reason is what? You need to specify the reason. Since m, the value m is less than n. The value m is less than n. That's why it is not possible to construct. That is what we can say that we cannot find out onto function between set A to B. Moving on to next sub question. How many functions are there from B to A? So as you came to know what is the formula for A to B, here cardinality of B to the power cardinality of A. Now you can only guess. So from B to A will be what? Revert this. Cardinality of A to the power cardinality of B. That is what I have found out. See here. I have just applied the formula cardinality of A to the power cardinality of B. What is cardinality of A? You know, that is 4 power 6. 4 power 6. Calculate 4 power 6. You can use your calculator. 4 power 6. 4 power to the power 6 plus equal to, you are going to get 4096 is the answer. So this is the way of using your calculator and you got the answer. So then I need to find out next how many of these are onto function from B to A. So in the previous question there was no onto function. Now I am seeing the mapping from B to A, the set from B to A. From the set B to A, therefore the value of B, the cardinality of B is 6 here and the cardinality of A is 4. Definitely I can say that n is greater than 4. When n is greater than 4, what is the formula? We can have the standard formula. So the standard formula is given by P of n comma m is equal to summation k equal to 0 to m minus 1 power k m c m minus k m minus k whole power n. That is the standard formula. So in place of n it is 6 and in place of m I have 4. Substitute those values. So I am going to get summation k equal to 0 to 4 minus 1 power k 4c 4 minus k 4 minus k whole power 6. So expanding this, k runs from 0, 1, 2, 3, 4. I need to find out set of 4. So when k equal to 0, what is the value? When k equal to 1, what is the value? Means I am going to substitute k values here. When k equal to 2, what is the value? When k equal to 3, what is the value? When k equal to 4, what is the value? That is what I am going to do. When k equal to 0, what we are going to get? Minus 1 power 0. 4c4, 4 minus 0 whole power 6. So 4c4 is 1. So minus 1 power 0 is 1. You are left out with 4 power 6. That is what? 4 power 6. 4 power 6 minus how we got minus means substitute k equal to 1. So minus 1 power 1. Minus 1 power 1 is how much? Minus 1. 4c 4 minus 1. 4 minus 1 is how much? 3. So that is 4c3. That is what I have written here. Minus 4c3. 4 minus 1 is what? 3 power 6. That is what I have written the second term. Plus the third term. When I give k equal to 2, what I am going to get? Minus 1 power 2. Minus 1 power 2 is how much? Minus 1 power 2 is plus 1. That is what I have started with. Plus 4c4 minus 2 is 4 minus 2 is 2. 4c2. 4 minus 2 is what? 2 power 6. 2 power 6. That is what the third term I have written. Next, finally, if we give k equal to 3. Minus 1 power 3 is what? Negative. As we have odd power here. So therefore we are going to get minus 1 power 3 is minus 1. So minus 4c4 minus 3 is how much? 4 minus 3 is 1. So we need to find out 4c1. We can calculate what is 4c1. See here, I will show 4. So shift divided symbol c1. 4C1 is how much? 4. So that is what I have substituted. 4. 4 minus 3 is how much? 4 minus 3 is 1. 146 is how much? 1. So finally I left out with 4. So finally I will substitute the last value k equal to 4. 4 minus 4 will be what? 0. 4 minus 4 will be 0. So 0 into a real value will be 0. So the last value is 0. So simplifying this using your calculator, you are going to get the answer as what? 1560. 1560 is the onto function from the set B to A. Now we shall see how many one-to-one functions can be formed from B to A. So definitely we can say that there is no one-to-one function from B to A. According to the definition, it is not possible. The reason behind that is since the value n is greater than m. The value n is greater than m. It is we cannot find out any one-to-one function from set set B to A. So this is what the solving the problem question number 3. Moving on to question number 3b. So this is what the given question. Let A equal to set 1, 2, 3, 4, 5 crossed with another set 1, 2, 3, 4, 5 and define R on A. They are defining a relation R on A by what? X1, Y1 related to X2, Y2. The ordered pair X1, Y1 is related to X2, Y2. It is defined as if x1 plus y1 is equal to x2 plus y2 is defined as what? X1 plus y1. The whatever the relation ordered pair here x1 comma y1. The left hand side will be sum of those two values which is equal to the right hand values will be these values x2 comma y2. That is x2 plus y2. x2 plus y2. So now going with the first question there in that verify that R is an equivalence relation on A. Verify that R is an equivalence relation on A. Then determine the equivalence class of 1, 3, the ordered pair 1, 3, 2, 4 and 1, 1. We need to find the equivalence class of 1, 3, 2, 4, 1, 1. We need to find. So let us verify first whether the given relation satisfies equivalence relation or not. So to define equivalence relation, what you should know the definition of equivalence relation. To verify that R is an equivalence relation, R should satisfy what? Reflexive, symmetric, transitive. So if these three satisfies, then we can say that the given relation R is equivalence relation. So consider for all x, y belongs to A cross A. So I am considering a ordered pair x, y which belongs to A cross A. So that implies what? X comma y belongs to A cross A means, so we are defining this R on A as what? X comma y related to x comma y. So when we know that x1 comma y1 is defined as what? X1 plus y1. Similarly, I can write down that left hand side as what? X plus y. Similarly, what will be the right hand side? X plus y. When xy is related to xy itself, we can say that xy plus x plus y is equal to x plus y. We can say that therefore R is an reflexive. R satisfies reflexive relation. Next, moving on to further. Now we need to prove that is it symmetric or not. So now let x1 comma y1. I will consider an ordered pair x1 comma y1, x2 comma y2 belongs to an Cartesian product A cross A. So by the definition, then x1 comma y1 related to x2 comma y2. So whatever the given relation, I am considering that relation. So using that definition, whatever the definition x1 y1 related to x2 y2 is defined as what? X1 plus y1 is equal to x2 plus y2. Using that relation, so according to the definition, we can write what? X1 comma y1 related to x2 comma y2 can be defined as x1 plus y1 is equal to x2 plus y2. So that is what I have done. X1 plus y1 is equal to x2 plus y2. So if I say that the value 1 is equal to 2, Can't we say that 2 is equal to 1? Think of it. When the value 1 is equal to 2, can't we assume that 2 is also equal to 1? So definitely, right? Like that, as we know that LHS is equal to RHS, that's what I have done here. X2 plus Y2 can also be written as X1 plus Y1. So finally, using the definition of relation what they have given, using that, I can write this as X2 Y2 is related to X1 Y1. That is what called as symmetric relation. R is preserved with symmetric relation. So if x1 comma y1 is there, x1 comma y1 is related to x2 comma y2, then it is satisfying x2 comma y2 is related to x1 comma y1. So therefore R is symmetric. So finally, if you take x1 y1, x2 y2, x3 y3 belongs to Cartesian product A cross A, then x1 y1 related to x2 y2 is defined as like this. Similarly, x2 y2 related to x3 y3 is defined like this. So then, as you know that, see, observe here, x1 y1 is equal to x2 plus y2, right? Here when I take this definition, x2 plus y2 is equal to x3 plus y3. So therefore I can say that x2 plus y2 can be replaced by what? X3 plus y3. So just that is what I have done here. X1 plus y1 is equal to x3 plus y3. I am getting the final solution. Therefore, using the definition of the given relation, I can say that x1 y1 related to x3 y3. Therefore, R is transitive. Therefore, I can conclude that R is equivalence relation on A cross A. Here, be careful. Giving the conclusion is very important. You are supposed to provide the solution properly and write the conclusion properly. Now we will go with finding equivalence class of the value whatever they are given. So 1 3 equivalence class of 1 3 I need to find. So I need to search for the value such that ordered pair 1 3 saying the definition whatever they have given. X comma y belongs to A cross A is defined as what? X plus y, right? X comma, yeah, that is what the definition they have been provided. X comma x1 comma y1 related to x2 comma y2 will be what? X1 plus y1, right? Like that, x comma y I have considered, that is x comma y belongs to A cross A such that x plus y will be equal to what? 1 plus 3. So 1 plus 3 is how much? 4. I need to search the value such that when I add the two components or two elements, I need to get 4. So by using the relation called A cross A. So from the relation, these two relation A cross A. So 1 1 is there, 1 2 is there, 1 3 is there, 1 4 is there, 1 5 is there, like that. 1 2 1 3. If I add 1 3, I am getting 4. Similarly, I need to search the value such that when I add, we should get 4. So 2 2 means 2 plus 2 4. Similarly, you need to find like that. So sum of those two values should be 4. So such relation can be satisfied here. I am writing such relations. So that is 1 3 2 2 3 1. These are the equivalence class of 1 3. Equivalence class of order 1 3. This is what the equivalence class of set order 1. Similarly, what will be equivalence class of order 2 4? So 2 plus 4 will be equal to how much? 6. I need such that I need to find the ordered pair getting the sum of two values as 6. So 1 is 2 4, 4 2, 3 3, 1 5, 5 1. These are all the possibilities of ordered pair getting 6. Sum of those two as 6. So therefore these represents the equivalence class of 2 4. The equivalence class of 2 4. Similarly, equivalence class of 1 1. I need to find equivalence class of 1 1 is what? The set 1 1 itself. So 1 plus 1 is equal to 2. There is no more ordered pair getting 2. The sum of two elements getting 2. So therefore the equivalence class of 1 1 1 ordered pair 1 1 is 1 1 is. This is the way of solving the equivalence class problem. So moving on to last part of question number 3C. So they have been asked the definitions. So under graph theory, there are so many definitions. They have asked a few of them. So one is simple graph. I will go with directly to the solution. Define simple graph with one example. So they have asked. So when we say that it is a simple graph, a graph which has no multiple edges and no loops is called a simple graph. So then the example is, this is what the example I have taken. You can take this example or this example. So go with this example since I am going with common types of graph. So go with the second one, V1, V2, V3, V4, V5. So take this example. When we say that it is a simple graph, a graph which has no multiple edges and no loops. A graph should not contain any multiple edges and no loops, then it is called simple. Go to the next definition. Complete graph. Any simple graph, if you consider whatever the definition came to know, simple graph, any simple graph is said to be a complete graph if each vertex is connected with all other vertices in same graph, then it is called as complete graph. Whatever the simple graph you are going to consider, in that simple graph, how many vertices will be there? All the vertex should be connected each other. Then we can say that it is a complete graph. Here I have taken K4. It is denoted by Kn. It is denoted by K suffix n. So I have considered K4. K4 represents 4 represent number of vertices. So I have considered 4 vertices graph. So V1, V2, V3, V4. Here V1 is connected with all the 3 remaining vertices. Here V1 is connected to V2, V3, V4. V2 is connected with V1, V4, V3. V3 is connected with V4, V1, V2. Similarly, V4 will be connected with all the 3 remaining vertices. This is what called as complete graph. Moving on to next definition, subgraph. When we can say that subgraph, you know the definition of subset, right? When we say that it is a subset, if the elements contained whatever the set we are going to consider, from that set the same element should be contained in the original set, right? Then we can say that it is a subset. Like that, if we consider any graph G, from that graph G, if you construct a new graph using those vertex and those edges, that will be a subgraph. So see here the definition. Let G equal to V, E, ordered pair V, E, and a new graph called H equal to V1, E1, be two graphs. Then H is said to be subgraph of G if V1 is a subset of the original vertices and E1 is a subset of original edges E. So this is what the example I have considered. If this is just a rectangle, I have considered G. So from this G, I have taken only V1, V2, V3. This is what graph H. Then it is called as subgraph. Now moving on to next definition. Spanning subgraph. What is spanning subgraph? A spanning subgraph of a graph G in a subgraph containing all the vertices of G. See, in subgraph, I did consider vertex V4. Then also we say that it is a subgraph. But in the case of spanning subgraph, how many vertices are there in original graph? That same vertices should be there, but not all the edges. Okay. So we can say that, see here the example. So G is this graph V1, V2, V3, V4. I have considered. Then I have considered V1, V2, V3, V4. I am not connected with V1, V2, V2, V3 is not connected. This will be called as spanning subgraph. Then I can say that H is a spanning subgraph of G. H is a spanning subgraph of G. This is what called as spanning subgraph. We all got to know a spanning subgraph of a graph G in a subgraph containing all the vertices of G. This is what the definition. So going with the next definition, induced subgraph. After coming to know what is subgraph, spanning subgraph, let us see induced subgraph. A subgraph is said to be an induced subgraph if it contains all the edges of G which joins the points of edges. Means what? In this graph G, whatever the vertex you are going to consider, this is what the graph G. I am considering another graph G1 as what? From this V2 is connected to V3. I am showing V2 connected to V3. V3 connected to V4 I am showing. V4 connected to V5 I am showing. V2 connected to V5 I am showing. This is what called as induced subgraph. If I keep this as it is, you should get as the same graph. Moving on to next definition. Complement of a graph. What is complement of a graph? So a simple graph with the same vertex as in the graph G, where the vertices will be adjacent in complement of G, if and only if they are not adjacent in the graph G. I think you didn't get the definition. See, it is very simple. Whatever the graph you are going to consider G, so in that vertex what we have, if there is no adjacency, means if that vertex is not connected with another vertex, connect that, that will be the complement of the original graph. That's all. Here V1 is not connected to V3, connect that. V2 is not connected to V4. That is what called as complement graph. Understood? So if I bring this G complement to G, if I insert this G complement to G, that will be a complete graph. That's all. That will be a K4 graph. Understood now? Very simple. This is a logic. Finally, last definition, Euler circuit. So what is Euler circuit? Consider a connected graph G. It should be a connected graph G. We are supposed to consider connected graph G. If there is a circuit in G, that contain all the edges of G, then the circuit is called an Euler circuit. Okay. So consider a graph G. I have considered a graph G here. V1, E1, V2, E2, V3, E3, V4, E4, V1. That is what called as Euler circuit. It should be a connected. Yeah, all the vertices are being connected. And what is the circuit definition? It should be a closed walk. I have considered a closed walk. So in that circuit, I have established a Euler circuit, that is V1, E1, V2, E2, V3, E3, V3, V4, E4, V1. That gives an Euler circuit. So this is the way of answering the given question. So if you all understood, kindly do subscribe to my YouTube channel and also share this video with your friends. It may be useful to them also. I thank you once again for watching this video. Thank you all.